episode. All right. Welcome, everybody, to another episode of Talking Cloud. As usual, I'm Brett Travers.
Yep.
And we have a guest this week. David is joining us. So we're going to talk a lot about, I'll have you introduce yourself here in a second, David, but we're going to talk a lot about different use cases of AI and David's experiences over the years. So lots of great stories to tell. So thanks for joining us, David. We were talking sort of before we got started about what's the odd banter that we normally start with. I can't think of anything off the top of my head. We usually start with weather or video games or something like that. But yeah, actually I do have something, and I joked with you last week. Claude code continues to break my Battlefield 6 addiction. Although I think I'm more sleep deprived now than I was when I was playing Battlefield. So there you go. That's my off-topic start for the week.
I feel like there's going to be a new syndrome that comes out for developer addiction, but
yeah,
I don't know how you feel about that, Dave.
Yeah, any thoughts on that before we start?
How do you use Claude to break a video game addiction?
I'm substituting one addiction for another, I think, is what I'm doing.
Okay.
Yeah.
I thought maybe you were having Claude play it for you or something.
No. Yeah, no, not that fancy. Just getting myself into different projects and stuff rather than spending my evenings grinding through levels in Battlefield. So yeah, there you go. All right, David, why don't you give us the quick bio and intro, and then we'll jump in.
Yeah, so a little about myself. I've been programming since 1982. I started out on the VIC-20 that my mom brought home from the Internal Revenue Service to use for work. And I quickly took it over and began to do graphical programming and other things. And then proceeded to run a bulletin board system throughout the 80s called Texas Outlaws BBS, where we essentially, hacked software and made it available online, which was a lot of fun because you had to call somebody up and say, hey, could you go switch the copy disk so I can get this code?
Yeah.
Or get this program. And then, in the 90s, went to school and in the early 2000s, got a PhD in distributed computing and AI. I think I had 3 advisors altogether. As I like to say, everything's been downhill since. So kind of the crowning achievement of our work in graduate school was we ran an application on 9.9 million CPU cores at Lawrence Livermore, and then went into the NSA. We started doing things on hundreds of thousands of processors, and just have constantly been making our way downhill. So now we're doing things in Kubernetes and using containers, and we don't even really know how many processors we use anymore.
That's awesome.
So
very good. I meant to mention this to you when we were talking earlier, and you mentioned the VIC-20. Made me smile because I got started on a Commodore 64 with a tape drive, and typing computer programs out of Byte magazine, if you remember that. And I remember the day I managed to get upgraded to a 5141, I think it was, or 1541, the 5 1/4 floppies. And then me and a buddy figured out how if you punched the corner of them, you now had a double side floppy. And we even got to the point where we modified that drive, and it had toggle switches on it because we were also running a BBS. And that way we could just toggle the switches so you could read both sides of the drive at the same time. Yeah, the good old days, right?
We used to use a hole puncher to make that. We do still have my official puncher. So eventually,
do you really?
Yeah, an actual puncher for that.
That's fantastic. I have the Commodore 64. I have my original drives and remember the CRT that you got with it, the Commodore CRT? I have them all in my basement still. And one day I will pull those out and find out what's on all. Well, I don't think I could bring myself to do it. Yeah. I would have to try to start putting those 5 1/4 discs back in there and see if I could remember how to load them up. Yeah.
So I remember being so excited the day I got my 4 megabyte RAM expansion cartridge that you could just hop in the back.
Yep.
That was Commodore history.
That's fantastic. Yeah, I remember being excited when I went from a 1200 baud modem to a 9600 baud modem. The problem was 300.
1200 E's modem was a big deal.
Oh yeah. You still had the problem of somebody picking the phone up in the house though. No matter how fast it was, yeah, you still lots of yelling matches in the house. I'm on the computer. Hang up. Yeah, because you didn't want to start that download again. Awesome. That's great. Well, thanks for the intro. When we talked before the call, I wrote down the thing that grabbed outside of the VIC-20. The thing that grabbed my attention was your early experience on AWS and how you got started in AWS and kind of what you were doing on that platform early on, I think before people even realized sort of what cloud computing really was all about. So I know there's still a lot of debate, in large organizations whether cloud is safe, but I'd love to hear sort of about your early experiences and what did it look like sort of those early days?
So when I started in cloud, I was a beta tester and an advisor for VMware going back way, way back. And as I graduated school, I went to work for the Mito Corporation down here in around DC in McLean, Virginia. And they needed people at the NSA who could do large scale distributed compute. And at that time, I was working with the folks at Yahoo to scale something called Hadoop from 2,000 CPU cores to about 10,000 CPU cores. And so the NSA grabbed a hold of that. They got word of that and said, yes, you're a guy we need on our team. I was working for General Alexander at the time to build out what we call the cloud compute environment. Now, what we call the cloud in 2005, 6, 7 is very different from what we think of as cloud today. I would say that a cloud back then was much more of like a big data platform. We were much less focused on compute and storage and those types of things, kind of providing infrastructure, and much more focused on providing access to large amounts of data and things that you could do with it. So computing frameworks and other things. We did have to do the virtualization. We did have to do storage and all those other things, but it was all towards the end goal of being able to get petabytes of data into the cloud. So we began to develop those in what we call CANs, or portable optimized data centers. It's a tractor trailer body.
Okay.
And it's got racks going all the way down it. They're usually about 50 U racks, and you just load it up with servers and you could put that thing anywhere on the wall. So we built our first one of those in 2005. And then my boss at the time took me over. We were going through Silicon Valley and just talking to everybody about everything that they were doing. We talked to, believe it or not, one of the most interesting ones that we talked to was Ancestry.com. Because identifying people and linking people and attaching people is a very, very, and searching databases in the background to find those source materials is very similar to a lot of what we do in the intelligence community. But yeah, 2005, we did get around to meeting Jeff Bezos and the Amazon team. And I was sitting there and they said, do you want to try it? And I said, sure. And so Jeff turned to an engineer behind him and said, give him an account. So I've had my Amazon account since before the beginning. I actually still have the same account, even though I don't really, because I pay for it, right? Yeah. So I wish they put the little thing on there that said, like member sense, because then,
you get like a little check mark or something like that, right? Yeah, you should. Yeah. I meant to look before the call because I know you can go in and see, like, I think it's a create date or something like that. And I was interested to see the create date. I still have my first AWS account as well. It would be nowhere close to 2006, but I now it's kind of like looking at uptime in your computer. I'm kind of like, wonder how old that account is. I'm going to have to dig it up and have a look at it. That's really cool little origin story.
Yeah, that's awesome. I mean, it kind of reminds me, like, you can never underestimate the bandwidth of a truck full of storage, right? Essentially for data.
you just hit on the Achilles heel of the entire thing, right? So we spent literally millions of dollars on just the networking equipment, right? Top of rack switches and, layer 3, layer 4 switches. And you take that entire thing, you put it on an Antonov, you fly it to Afghanistan. I actually went with the system. You land, you install, you put on the chillers, you connect it all up. And the network that you're attaching to has about 1 gigabyte of overall throughput for every single computer on the base.
Wow. Yeah. So bandwidth is still the problem.
Yeah.
Yeah.
And getting network was an issue. Yes, we were purchasing 10 gigabit networks back in 2006, 7, 8. They were great when you were inside of the environment, and they're great when you're running analytics and other things, but try to get access to large amounts of data and get it on the screen. That was a real challenge for the user.
Different stories. Yeah. Yeah. That's neat. I remember talking about tractor trailers and compute and everything in storage. I remember, I don't know what year it was, reInvent, when Amazon announced their Snowmobile. I can't remember. Remember those physical devices? There was the Snowball. Yep. Yeah. And then there's the tractor trailer. And I remember being in Vegas, typical Vegas thing, right? And they're doing the keynote, and they drove the tractor trailer out in the middle of the keynote. I think it's been retired since. Like, I don't think it's a service they offer anymore. I think it's all been deprecated. But I still remember they had it in the vendor area. You could go up and look at it and everything. And it was essentially a 52-foot trailer full of storage. Came with its own security, came with like exabyte network connectivity. I'd be interested to know, they told a story, but I can't remember who it was. They had demoed it with a customer in the States somewhere. I can't remember who it was. They were doing satellite imagery or something like that, and getting it all into the cloud was sort of one of their early customers. And they ordered one of these devices and plugged it into their network. So yeah, tractor trailer computing, who knew, right?
So the one mistake you never want to make with your tractor trailer in Afghanistan is leave the door. Because just leave the door open, it snows, and now you have snow in your body.
Oh, yeah. I was thinking like heat and dust, but yeah, they have a wide range of climate, don't they?
Absolutely. Who would imagine?
Yeah.
Who would imagine going into the office and seeing snow?
Yeah. Yeah.
Maybe that's where the name comes from. I wonder. That's funny.
Yeah, that's funny. The other thing that you'd mentioned when we were prepping was your early work. I think it was PhD work that you'd mentioned about parallel simulation and working on sort of processing large amounts of event data. I'd love to kind of go back in time with you there and talk a little bit about sort of the origin story of that. How did it get started? How long did it sort of take you to get, I'll use the term MVP. Like, how long did it take you to get that going?
Yeah, so we built a what's called a parallel discrete event simulation system. And people have been building these going all the way back to 70s. And actually, you could trace the lineage back to the 50s, in fact. And you can develop a non-parallel, a sequential discrete event simulator in about 10 lines of code. But a parallel discrete event simulator ends up being about 50,000 lines of code. Somewhere between 5 and 50,000. Yeah, my PhD advisor, when I was a brand new graduate student, said, "Hey, I'm going to go present a paper in Germany. I'm going to be there for 2 weeks. I need you to house sit my dog." So my buddy and I, fellow graduate student, house sit his dog for 2 weeks. Worst dog in the world. For that I've been working on for several years. And we tried and we could not make it work. So we clean room designed it and rewrote it from the ground up in that 2 week period. Now, it took about 2 years for it to become stable, and it was 2013 before we ran it on just shy of 10 million CPU cores at Lawrence Livermore. But I think it may be the world's largest monolithic application that's ever been run. And what can you do with it? Well, you could do lots of things with it. You could do mobile radios. You could do like cell phone networks, right? You could simulate billions of cell phones walking around in 3D space, doing, actual partial wave dynamics. You could do chip design. That's a very popular use case for it, is chip design. Although that's been taken over by AI now. So I
Right.
don't think anyone can use that anymore. And a multitude of other things. So it's really good at modeling things where you do not have a mathematical formulation for them. So think human behaviors, think decision-making processes and stuff like that.
Pandemic spreading, maybe, that kind of thing.
Well, pandemic spread, so that's an interesting one. During the COVID years, we did use it for pandemic spread. Pandemic spread is expressed by the SEIR differential equation, ordinary differential equations. But what we did with it that was unique is, so first we had to discretize that, which means get it into discrete time units. But what we were able to do with that is we were able to apply human behaviors to the model. So, whether or not somebody was likely to wear a mask or get vaccinated, or, did they stay home from work? Not everybody can stay home, right?
Oh, sure.
Not everybody can work from home. And so what we used it for, we used it throughout the federal government for a number of different use cases. In the end, I think we were modeling about 5 or 6 billion people around the world. In high fidelity. So at the individual level, as people go from room to room, get in a car, get in a bus, go to the grocery store and other things. You can use that for a multitude of different things. We used it to do what-if analysis for different areas around the United States, and the U.S. Northern Command and the National Guard used it to plan for where to send PPE doctors, nurses, and estheticians around the country. We used it in the EU with EUCOM and the Army. When they would do a training exercise, and they were going to send 2,000 soldiers to Poland. They wanted to know, what do soldiers do when they're, on a training exercise, right? They go out to bars and other things. So we wanted to know what kind of environment we were sending them into. And in the intelligence community, we used it to assess the force readiness of the different troops in Ukraine, Belarus, and Russia. So I've got a laptop that probably has about 400 viruses on it from Russia. But collecting data from Russian state agencies is definitely an interesting one.
Yeah, that's great. What else do I have on my cheat sheet here? Let's talk a little bit about, I think there was a good segue in there because you mentioned about sort of early use for chip design and stuff, and how Gen AI has sort of replaced that. I'd love to know a little bit about some of how in your current life, I'll call it, what you're working on right now, how are you dealing with LLMs, Gen AI, large amounts of distributed data? Just kind of maybe shed some light on sort of how you went from those early models or early solutions to how you're working with large data now.
Yeah. So, it's probably, I think we could all agree, not a great idea to let Claude go run amok over, classified data.
We can agree.
Yeah. Non-classified data, you probably don't want it to run amok on either. We've seen some stories over the last couple episodes about stuff going sideways on folks when they weren't maybe thinking it was going to happen, right?
Oh yeah, deleting and rebuilding entire systems, right?
Yeah.
Yeah. So you can imagine how much fun that might be in a classified environment, right? When those systems happen to be tied to their weapons with, large scale explosive.
Yeah.
Yeah. No, what we've really focused on in that space more than anything is really trying to bring, decision intelligence, what we call decision intelligence and decision governance, to the LLM problem or the Gen AI problem. Not just in the government space, but in the commercial space as well. And so what that really means is kind of flipping the model on its head a little bit. I think there's a multitude of people right out there right now generating MCP servers to provide tools to LLMs for their different capabilities, right? I'm using the Brave browser right now, and they have an MCP server that lets you drive Brave, lets an LLM drive Brave. And so that seems to be the thing of the day. What we're doing is we've actually moved the LLMs down into the MCP server in order to be able to have better control over them and put better guardrails around them and put real decision intelligence inside of them. And so what that enables us to do is we have LLMs inside of the MCP server that are tracking the decision-making process across these organizations, which is creating its own data set about how an organization makes decisions. And then we leverage that information. We're essentially constantly fine-tuning and training LLMs on that decision-making process and measuring where are bottlenecks in an organization, right? Where do decisions go to die? That's usually on my desk because I'm really bad at paperwork. High organization and non-compliant. But then we also look at, how well, how static are the decision-making processes, right? Because for many organizations, it's really important that they not, become too static and frozen in how things are done. Otherwise, they're not able to, modify how they do things over time. So, we measure the plasticity of decision-making process. We measure a lot of different things and try to use that to constantly or iteratively improve their decision-making process over time. But you have to do it in a way that, maintains governance, provides auditing, attestable. They have to be attestable. Always have trouble with this word, attestation. But you have to have attestation in the system in order to know that the evidence used in the decision-making process is kind of frozen in time so you can go back and review it and have confidence in the decision made. You see this in the IC domain all the time, right? There's a pretty big story, pretty sad story a couple of weeks ago, right? With the bombing of a school in Iran. That's something in the intelligence community for, decades now, right? Someone in the intelligence community is going back through that audit trail and reviewing that intelligence and how it was built to try to understand exactly the decision that was made that led to that outcome. And so they're going to trace that all the way through. And that is what we are bringing to this whole Gen AI LLM world is that same type of tracking so that people can have that, not just for really serious things like life and death situations, but also for less important things like what's happening in our company.
Yeah. It totally makes sense because the tricky bit is the reliability or repeatability problem, right? So if you have like a database log, I guess I'm imagining how this works is you have a log of every decision that's been made, then you have some observer models that are kind of monitoring that as events occur, right? And then you can essentially go back and look at all the inputs to that decision. So yeah, that's really interesting in terms of like a solution to this problem.
And then what our MCP service is doing, Travers, is it's adding additional tools to make that process more robust, right? So before you can make a decision and assign tasks to it, right? Because you want to take an action, we require, sources of evidence, right? We build something called an addition. Addition is essentially, just a written record of why is this decision important? Who is making the decision? Who is involved with it? Who, approves, rejects, or abstains from a decision, so that you have all of that. Many organizations don't have that. In fact, when we talk to many places about it, we could tell almost instantly how mature their processes are because they say things like, that means you're going to connect to my email. And I'm like, that's how you make decisions. Somebody emails you and you say yes or no. That's not really what we're talking about. What we're talking about is, in the healthcare space, how decisions are made to, reimburse or deny for a medical procedure based on the diagnosis that also contains lab results. And so you've got data like kind of throughout that system. And that's where the federated learning comes in that we really specialize in and focus on is, being able to interconnect all those different data silos together and create a decision-making layer or process on top of that.
Gotcha. There's like a standard of evidence that you're looking for to gate these decisions. Right. Okay.
That's right.
And when you're talking about federated learning or federated training, so I assume that means you are kind of you're going to the data and you're training locally in that silo, I guess, and then you're assembling that somewhere else. Is that the kind of process, or maybe walk us through that?
So federated learning is all about moving the computation to the data. So just as you described, right? Maybe you have 100 terabytes in Amazon, GCP, and Azure Cloud. You can centralize all that data in one spot. You can put it all in Snowflake and wait for it to get hacked, or you can leave the data where it is. I have to apply better than that.
You got it.
Or you can leave the data where it is. And as you suggest, you could train on your data locally. So what we're doing is every 10, every 20 epochs, we exchange the model weights and losses with what's called an arbiter. And we use that, and what that arbiter is doing is it is averaging. There's a few different mathematical techniques, but the most common is federated averaging. And what we're doing is we collect all the weights and losses from Azure, Google, and Amazon, average them together, and send them back out again. And when you're doing averaging, of course, it's mostly addition. So it's pretty efficient. We do that using homomorphic encryption, so that, because now we have to do things like protect the models instead of the data, right? So if I'm not moving the data, I leave the data where it is, I'm moving model weights, model losses. I have to now think about my new threat surface, which is the model. And so we use homomorphic encryption to keep everything encrypted over the wire, on disk, and in memory. But then we also use other techniques like garbled circuits to fuzz the model, such that even if somebody were to get access to your model, they would not be able to reconstruct your training data from it. So I have a number of different techniques. There's also differential privacy, secure multi-party communication, and a bunch of other techniques we use, all of which is just to protect that model.
Yeah. Makes sense. I mean, if the weights leak, that's everything, right?
That's right.
So, reason.
And I don't know with common knowledge, but you can reconstruct training data from a model. So
yeah,
I would be able to back into the data.
Well, that's how you get the cheaper models from some of the Chinese labs, right? Like your GLM models, that kind of thing. Sorry, Brett, I think I cut you off there.
No, that's fine. That's fine. I wanted to back up a little bit and talk more about the comment that you made about, I think I'm going to paraphrase what you said, but getting the MCPs closer to the LLM. Is that how you worded that? I'm interested in kind of what exactly that means, if I'm understanding what you said correctly.
So the common pattern is that you have an LLM, and that LLM is capable of leveraging the tools that have been created inside of an MCP server. So an MCP is all about, right? It's an API that exposes tools and capabilities of your software application to the LLM. And that's fantastic. And we support that model and we implement that model all the time. But in addition to that, we put LLMs inside of the MCP server itself. And so there's additional decision-making that's happening inside the MCP server as it's being used by an external LLM.
Okay. So if I paraphrase that back to you, like you've got something happening in LLM, it makes a tool call to an MCP. Part of that tool is another LLM that's doing some sort of reasoning in that call that it received. Is that okay?
That's exactly right. That's exactly right.
Yes.
If we go back to like the example of the Brave MCP server, Brave says, it's a browser. You can do whatever you want with it. You can go visit the web. You can go visit the dark web, and you can use that for, it's a tool, right? So you can use the tool for great things like launching services in Amazon. But you can also use it for nefarious purposes as well, right? Like launching a hacking tool, Amazon. And so in our MCP server itself, what we're trying to do is make sure that none of those nefarious things are happening with the tools that we provide.
Okay.
So gives a bit more control over it, gives intent to it. A very concrete example is often people will upload a file and they'll say, hey, I want you to go and process this. What we're doing is we're looking for leaks in an organization's data. So now your LLM reaches out and says, hey, I want to know more about this. And we say, no, you don't. You're not supposed to know that. We're not.
Okay. Got it. Yeah. Got it.
Are you guys checking for attack vectors too, like a prompt injection or things of that nature? Or yeah,
absolutely. So a number of different things. So, and funny enough, the biggest thing that we really focus on is convincing the Gen AI, the LLMs, that it's okay to say, I don't know. Right?
It's a hard problem. They don't want to say it. It's they're built to respond with an answer, right? For the most part.
That's right. Right.
Yeah. Huh. Yeah, it's funny. I'm going to talk about myself here for a second, because I was saying as we got started, I'm a little sleep deprived because I've been playing around with this stuff a little more than usual over the last couple of weeks, and just that idea of how do you get that LLM to say it doesn't know? I'm having sort of a similar but different problem in the sense, like, these are the instructions I want you to follow. You follow it 3 out of the 5 times. So why didn't you follow it those 4th and 5th times? Like, what was different about that? And it's really funny as you're trying to troubleshoot isn't the right word, but trying to, you're like, why didn't you do it? And it's just like, oh yeah, you're right, I should have. And I'm like, okay, but that's great, but why didn't you do it? What isn't in the instruction that you need to get you to 4 out of those 5 times, right? And the iteration that I've noticed over the last couple of weeks, just trying to get those models to do the same thing when you ask it, hey, I want you to go grab these issues and work on these issues. And I want you to do that independently. And it works perfectly fine for the first 3 issues. And then the 4th one is like, do you want me to fix this? And I'm like, yeah. Right. So it's interesting. You're saying, like, how do you make it say, I don't know, but how do you also make sure that it follows the rules? Or, how do you get it to do what you want every time in a
yeah, it sounds like a scaffolding problem, right? Like, in a repeatable way, get what you want.
Yeah.
It's like, it sounds like kind of what you guys are doing is you're building a system around these fuzzy logic models, essentially, that's trying to get a better result. David, you can talk more about that, but that's what it feels like.
Well, the reality is that the systems that are connecting into us, right, we don't have very much control over. Right? We don't have very much control over the LLMs that people use. And so when you're a system, when you're a federated learning platform and you have access to federated data across the enterprise, you need to really make sure that, you can't trust the LLM that's using your tool. Right? So it becomes almost like an adversarial or insider threat problem, right? Where you have to ensure that, is this agent who they say they are? Are they acting on behalf of, who are they acting on behalf of? And so there's a whole multitude of issues that go into it, in addition to just very basic things like, are we giving them access to data that they're not supposed to have access to?
Right.
But to Brett's point, I imagine, I don't know if you have children or not, but sometimes I feel like I have an extra child when I'm working with, a tool like Claude. Mm-hmm. Because I just want to dream on it. Like, I've told you 4 times.
Yeah. Yeah. I don't have kids, but I think that's a great analogy. And you were talking, Travers, about the scaffolding, and I was talking to somebody else about this, and his comment to me was, the company with the best scaffolding will win. And I'm like, oh, that's just such a great way to sum up this challenge, right? And I've been playing with a bunch of different agents over the last couple of weeks, and you can clearly see the difference in some of them. Like, okay, that doesn't work, so don't do it again. Okay, yeah, I'll try a different way. And then they do the exact same thing, and you're like, wait a second, I just told you not to do that. I'll try it again, and it does the same thing again. And his comment to me was, yeah, it's the scaffolding, right? It's sort of how they've put these systems together and how they'll react to that. But you're right. It's kind of like talking to, dealing with a young child sometimes, right? Yeah.
Having a 15-year-old.
Oh, that's fantastic. Travers, do you have any other Any other questions on your list there?
Well, it strikes me, it's kind of, in a way, I can see the tie back to the distributed computing parts of your work, right? So you're doing this training in an isolated environment, you're sending a message essentially back to reassemble in a central location, right? I'm kind of curious, like, what's the hardest part about that process for you guys? What's the most interesting part that, in your view, that's in kind of, I know you're solving this problem, but what's the part that stands out the most?
So the decision-making process has been pretty formally defined inside of the Air Force and used throughout the DoD for the last 30, 40 years. So that's not actually the challenge. The challenge is assuring that you have the correct data going to the right person at the right time, even if that person is driving a model, is also a relatively solved problem through attribute-based access.
Right.
But whereas this issue in the middle with the LLMs and keeping them on track, that is really the hardest part, because they are an amazing tool and they can do a lot of things, but that tends to be about as far as people think about it, or I should say maybe common everyday people think about it. Technologists like yourself think about it a bit deeper. So they do require quite a bit more capability behind them in order to really work effectively, right? So adding memory to them is a big deal. Trying to minimize context, even doing just basic things like really keeping the inputs and the outputs short to a model so that you can preserve its context for as long as possible, are really important things. And so getting all of that encoded properly, getting all of that developed in a kind of a middleware layer where you never know how it's going to be used is a really tricky thing, because we're constantly finding new things. We're constantly coming across, like, I guess I'll back up for a second and say, when we first started doing this, we thought, oh, this is going to be relatively simple. We have this doctrine, right? In the DoD, they have a doctrine for everything, including how to spend money and how to make decisions. So we thought
everything's going to
take. Yes. So we're just going to take this policy, feed it in. It's going to give us an app that implements it. We'll be done in 2 days. Yep. But we're finding that people are pretty amazing at working around things and getting around things and doing things they're not supposed to. And so we're just constantly finding different things that have to be, I guess, we might call them, corner cases, but we're constantly finding new ones in the decision-making process. So, and then, as I said, iteratively improving these models over time and having them learn, that sounds like a relatively easy task, right? That sounds like a nice thing. But what happens when the person you're learning from is really bad, right?
Right. There's a poisoning problem you can run into.
So you want to help an organization iteratively improve by learning off what they're doing, but you have to do it in a very specific way. Otherwise, you're just going to learn bad habits and spit them back out again. But you can help them iteratively, unimproved for.
So how do you try to avoid that poisoning problem then? Because like you've said, you don't really have any control over how people are using the tools, the inputs maybe going into those tools. So how are you protecting against bad learning from that?
Byzantine general problem almost at that point.
So there's a pretty famous example of how easy it is to take a tool like AI and make it bad, right? Use it for a nefarious purpose. There was a researcher in synthetic biology world. They had trained a model to develop a protein that would help you, right? And so they had labels in their data, right? It was a binary it was a binary classifier. And so they were like, yes, this is a good protein. That's going to help. This is a bad protein, right? That one's going to kill some, right? So at the end of the day, all they had to do was flip that binary and you could turn it into a guy that would bio it, right? Something
awesome.
that would go off and Very similar thing here. When people are making decisions that are out of compliance, we just have to make sure to mark them as examples of what not to do. So it's a matter of getting the labeling correct. And that really kind of highlights the challenge and why we're using an LLM. So that's where LLMs kind of come in is this in compliance, right? Is this a good thing or a bad thing, right? Because not just because something is out of compliance, just because something doesn't fit into a proper mold, that doesn't mean that it's necessarily bad. And so that's where the LLM kind of comes in and says, yes, this is a good thing, or no, they're just trying to make a decision with no evidence or no justification or not enough approvals, right?
Right.
So the LLM is helping us to kind of make those judgment calls from time to time and create that data set. So they're doing some cleansing, they're doing some normalization on the data that we're collecting. So then we can go back and train on it.
And you're fine tuning based on the acceptance standards and whatnot, I suppose.
Yeah, very good. Very good. Well, I've exhausted all of my questions. I don't, Travers, if you got anything else there, or
I have one thing I'm curious about. You guys aren't training any foundation models necessarily, right? Unless you are. But I was curious about, like, how do you deal with different architectures in this kind of distributed setup? Like, I know there are.
Oh, did we lose Travers? Are you still there, David? Or is it me?
Oh, I think I disconnected, didn't I?
Yeah, we disconnected for a sec. Try that again, Travers.
Where'd you lose?
Yeah.
Gotcha.
Yeah.
So for federated training of LLMs, like, for example, something that comes to mind is like a mixture of experts model, for example. You are going to be training, you have narrow activation paths, right, for specific problems. So how does that kind of architectural decision-making factor in? Is that something you guys account for, or are you dealing more with fine-tuning on the outputs of these foundation models?
It's more fine-tuning in the LLM space. So most of the federated learning that we're doing is with, training from scratch is not done with the LLMs. We can certainly do it with the LLMs, but most of the work is done on fine-tuning. So that just seems to be the use cases. That's what we focus on. So, LoRa tools and stuff like that to be able to do that effectively. And I'll be honest with you, we're constantly reconsidering and rethinking what we're doing. It kind of, at some point you get to a point where you have to ask yourself, can I ever train a model as well as these other people?
Right.
So for years, the open source community has really been ahead of OpenAI and these other commercial endeavors. At some point, if you just don't have access to the data, if you just don't have access to the people or the data centers, are you going to be able to keep up? And so that's one of the things that we think about on a constant basis is, are we going to move away from creating our own tools into just using? So that remains to be seen.
Gotcha. Makes sense. It's kind of scarce up the whole supply chain, basically, right?
Yeah.
People.
Yeah. I mean, it really does create a monopoly around a key technology, right?
I guess that's why we're seeing such massive investments, because everybody's trying to get that chunk right up front. We were talking about the amount of data Amazon's investing. What did we say, Travers? Like 200. What was it?
On that order, yeah. Billion
this year,
yeah.
Right? And you can imagine that the other big four, if you think about the other large company, they're going to all do the same. They're going to have to match it. So just the amount of money going in this to make sure that they have the infrastructure that people need, it's pretty incredible when you think about it.
Yeah. However, there are still really exciting things happening in the open space community. I was just reading an article this morning about Mamba 3 models being released on an Apache license. What they've specifically focused on is speeding inference and making that available to people, foundation models, inferencing on smaller scale hardware and making that really efficient and fast. Cool. It'll be interesting to see what comes out of that. And it's not coming from China. So there's an added benefit.
Yeah.
Well, it's still alive and kicking, and they're still doing some interesting things that I think we have to be looking at.
Yeah, that's awesome. One thing to add on that, Travers, did you happen to see the announcement from AWS and Kiro this week? Some of those additional models that are now available.
I didn't.
Some of your favorites, Quen, Minimax. There's a whole bunch of them. So that one caught me by a little bit by surprise, right? Because of so much investment in Anthropic from AWS. Just kind of thought it was always going to be Anthropic, but now they've got these other models available too.
Classic AWS diversification there, I feel like.
Yeah.
Amazon was the largest investor in both OpenAI and Anthropic.
Yeah.
Right.
Yeah. Yeah. Something else. Well, David, I want to say thanks. It's been a really great hour-ish with you. Outside of that weird little blip there, my computer held up the whole time, which is nice. Travers and I kind of joke every once in a while. It just does not agree with us, so I appreciate it. One of the other things that we like to do here is we sort of do a recommendation at the end. The recommendation could be anything. We talk about books, video games, movies. I'll kick us off. My recommendation is going to be one that I've used a couple times. Travers, you'll chuckle. We Are Legion, We Are Bob. I'm on, I think, speaking of sleep deprivation, it's contributing to that because I keep staying up reading these things. There are great light reading sci-fi. And the other one that I found, we were talking about Gastown just before we came online, right?
Steve
Yegi. He has written a book with Gene Kim. It's called Vibe Coding. And it's not vibe coding like people tend to think about vibe coding. If you want to read a really fantastic book like Gene Kim, DevOps, Phoenix Project, that guy, really fantastic book. Another one that over the last week I haven't been able to put down. So those are my recommendations for the week. Fun little reads, sort of related to the topic and 100% not. Travers, what do you got in your list this week?
I'm going to go see Project Hail Mary. That's out on Friday. So
Friday? Are you going IMAX or just like a lowly IMAX regular theater? Yeah.
Never tough one of these. And I've also been reading. Hold on, let me come back here.
Oh, he's leaving the screen. He's going to get a book.
Sorry, I'm long gone. Been reading a Michael Lewis book.
No, we were allowed to be there.
You just wander away. As he's getting props. What do you got?
Kind of loosey-goosey out here. I've been reading this Michael Lewis, The Premonition, which is why I had pandemics on the brain, David, when we were talking, but kind of a walkthrough of the COVID pandemic, and it's been quite good so far.
That Hail Mary might actually make me leave my house and go to a movie theater. That book, again, was absolutely fantastic. And I've been waiting for it, right? Like when they came out and they're like, we're making a movie. And then same thing I saw just the other week. They're like March, 30th or whenever it's coming out, IMAX. I think I might have to go actually see that in a real movie theater because if they do the book justice, that's my fear, right? As always. But yeah, I think that's going to be a great movie. Hopefully, fingers crossed. David, can I put you on the spot? What do you got? Anything? Yeah.
For you.
Okay.
I'm going to give you two. Because, we're computer geeks, right? Or go outside and climb a mountain.
Yeah.
Right?
Yeah.
That was a good one. You have to be able to see things that are more than a couple feet in front of your face.
Right? Yeah. That's good advice.
And then the other one is we get carpal tunnel a lot. So one of the things that I've been doing is I've been doing crochet.
Look at that.
Do a lot of dexterity. You can see on the couch there behind me, and it's a blanket that I made.
Oh my God.
Awesome. Fantastic hobby. And it really, works your wrists in a way that kind of undoes some of that damage.
That is so funny. I got a couple. That's a great recommendation. I got a couple crochet for beginners kits for Christmas. Because a Discord channel I hang out in, it's all tech guys. I shouldn't say tech guys. Let's just say tech professionals. And I bet you it's got to be more than 50% of them. They all crochet or knit. One guy's like a sewer, and he's always sharing pictures of the sewing project he had. So my wife bought me a couple beginner kits. My mom visited, and she's like, I have this great book from the 70s on getting started with crochet and all the different I'll call them knots. I know they're not knots, but all the different stitches and stuff. So she's bringing that to me. So there you go. I don't know if I could knit that blanket in the background or crochet that blanket in the background, but there you go. Yeah.
Prize is very much like pixel art.
Oh, totally.
That's awesome. Well, thanks very much, David. Again, it's been a pleasure. Really great conversation. Thanks for joining us tonight. I appreciate it.
I appreciate you having me. Thank you, Brett. Thank you, Travers.
All right, folks. Bye for now.